Hi, welcome back, Algebra 3 Trig. In today's video, we're going to learn how the first part in solving radical equations. As you can see in examples 1, 2, and 3, we're going to solve equations that have radicals in them. Radical equations have one or more variables underneath a radical symbol. Now I'm going to break this lesson up into two parts. We're going to start off with some easier problems in this first part, and then the part after this will be more difficult radical equations. So we are going to solve and check our answers after we're done. Remember, checking for extraneous solutions. So when you're solving a radical equation, you want to get the radical on one side by itself. So the first thing we're going to do here is add 4 to both sides. So now we have square root equals a number. Now, how do we get rid of a square root? Radicals are opposites of exponents. So a square root has an index of 2. So we're going to get rid of the radical, we raise both sides to the power of 2. On the left side, get rid of the radical and just drop down what was in the radical, called the radicand, and that's 3x plus 1. And do the squaring on the right. So remember, we're canceling on one side, doing the math on the other side. So then, it just turns into a simple equation that you guys have been solving since Algebra 1. You're going to subtract 1 from both sides. And then divide by 3 to have x is 5. Okay, we are going to check our answers, though, to see if 5 is definitely our answer. So we're going to put 5 in for the x into the original equation. So that'll be square root of 15 plus 1. That'll be square root of 16 when you add them. And then 4 minus 4 is 0. That is true. So 5 does work out. That's our solution. Okay, moving on to the next problem. Let's get the radical by itself. So first, we're going to subtract 4 from 7. Okay, now that the radical's by itself, we're going to raise both sides to the power of 3 because we have a cube root here. So when you have a square root, raise it to the power of 2, cube root to the power of 3. If you have a fourth root, power of 4, etc. Power of 3. So get rid of the radical, bring down 5x plus 7 on the left. And then we have to do the math on the right. 3 cubed is 27. And of course my neighbor has to do, if you hear that, my neighbor has to do their lawn at the perfect timing that I'm doing this lesson, right outside my window. Anyway, we're going to subtract 7 from both sides. We're just solving for x here. Some Algebra 1 stuff. And then divide by 5 and you have x is 4. And let's see if it is in fact 4. We are now going to check. So cube root of 5 times 4 plus 7 plus 4 equals 7. So that'll be 5 times 4 is 20 plus 7 is cube root of 27. The cube root of 27 is 3 because 3 times 3 times 3 is, or 3 to the 3 cubed is 27. And 3 plus 4 is 7, so that works out. I'm content that, without a doubt, 4 is my answer. Okay, let's try another one. So let's get the radical by itself. First thing I'm going to do, subtract 2. Now, the 2 that's to the left of the radical, we do have to get rid of that. You obviously never distribute with a radical. Now, this is hinting that the 2 is trying to multiply by the radical. So we're going to do the reverse of that, and we're going to divide both sides by 2. Next, this guy, now that the radical is by itself, we're going to get rid of it. We're going to raise each side to the power of 4. Be careful with the negative. Put it in parentheses. So it'll cancel the radical on the left. On the right, -1 to the 4th power is +1. If you don't use the parentheses there, you are going to get -1 and be wrong. And then obviously we would, as my voice cracks, we're going to subtract 11 from both sides. And now we're going to see, is -10 our answer? We are going to check our answer. So in the radical, that'll be -10 plus 11 is 1. The 4th root of 1 is 1, so it becomes 2 times 1. I know the 4th root of 1 has to be 1 because 1 times 1 times 1 times 1 is 1. Two times 1 is 2. And guess what? This is not going to work out. 4 is not equal to 0. So we're going to cross this out. We actually have no solution on this problem because we consider -10 to be an extraneous solution. So there's proof why we have to check our solutions. Okay, let's scroll down. Sorry for the pause there. I was just double checking. We are going to get some more examples in down below. Scroll down to, where is it? Assignment 3.4. Assignment 3.4, numbers go way down to number 30, and I'm going to show you a few more examples from here. So right now we do have the radical by itself, so we can go ahead and raise both sides. It's a square root, so we're going to raise both sides to the power of 2 to get rid of the radical. 3 squared will get 9. And now we're going to solve for x. Subtract 1 from 9 to get 8. And then divide by 4 to get 2. Now let's check the 2. 4 times 2 plus 1 equals 3. So that'll be 4 times 2 is 8, plus 1 is 9. And the square root of 9 is 3, so that does check out. 2 is 100% our answer. Simple. If you guys put in the work on this first part of solving radical equations, some of these are really, really basic and easy to get done. Just got to put in the practice. Okay, let's try out number 34. So we have the radical by itself here. So we are going to raise both sides to the power of 2 because it's a square root. So get rid of the radical. And here, this would be x equals 4, because you got to ask yourself, like, 5 minus what number is 1? Just use a little common sense there. X is 4. All right, so now we're going to check that. So square root of 5 minus 4 equals 1. That'll be subtract to get square root of 1, and the square root of 1 is 1. So that checks out good. That means that 4 is your answer. Okay, let's try another one here. Let's go to number 37. 37, we have a cube root. We do have the radical by itself on the left, so we can go right to raising both sides to the power of 3. So get rid of the radical on the one side. On the other side, negative 3 to the third power is negative 27. And then solve for x. We're going to add 2. And then we're going to divide by 5. And we got negative 5. Now we're going to check that. So 5 times negative 5 is negative 25. And then minus 2 is negative 27. And this is a cube root, so we are allowed to cube root negatives because the index is an odd number, that 3. So the cube root of negative 27 is negative 3. So the check works out. So negative 5 is my answer. Okay, let's go down to number 42. This is a problem where we have to get the radical by itself, so please do not square right away. You don't square, you don't do the exponent until the radical is by itself on the one side. What you need to do first here is add 5 to the 8. Now the radical is by itself on the left side of the equal sign. So we can raise both sides to the power of 2 since it's a square root. Get rid of the radical on the left. And on the right, 13 squared is 169. And then subtract 1, 168. Easy stuff. Now the check. Checking 168. So 168 plus 1 is square root of 169. The square root of 169 is 13. And 13 minus 5 is 8, so that's good. And we got our answer. We got our answer, 168. Okay, guys, I think that was enough practice for the most basic of radicals. Now, on the next video, you're going to learn how to solve some tougher radicals, which will be examples 4, at 4 and 5. You'll notice that these radical equations have an x that's not in the radical, and you'll see how that can be more difficult. All right, guys, this video is finished, so good luck on your work.